Good evening. I'm Jan. I'm a postgraduate student in electrical engineering. My student ID is 18211829. Today I'm here to present to you about how I solved the part 1 of renewable energy principle assignment. Firstly, I will talk about the sample calculation for the sun position angle at the given time and also determine the periods of daylight on this day. Then I will find out the sunrise and sunset on the 21st of each month of the year. Next, I will show how to draw the sun path diagram from that period, and finally find out the hour of shadowing by obstruction in different months of the year. I will start with some general information. According to the topic, we have to design a 3 kilowatt um, FTC rated quick connected PV array installed on the rooftop near the boundary with the location later given. The set of formula, the solar declination, altitude angle, and azimuth angle are calculated by the set of formula. Where L is the latitude angle and H is the hour angle. Both are given. Firstly, in part A, we have to calculate for the sun position at 6 a.m. On the 1st January. This means that the hour before solar noon is 6 and n is 1. So we calculate the h. Then we substitute n into the formula. We get the for solar declination delta. Next, we substitute L, delta, and h into the formula to get the altitude angle beta. Finally, we calculate phi s compare the condition of cos s smaller than tan L over tan delta, so phi s is should be larger than 90 degree. For the sunrise and sunset, beta is equal to 0, so that cos s equal to minus tan L tan theta. Thus, we can get the hour angle before and after solar noon. Secondly, we can calculate on the hour before and after solar moon on each 21st of each month of the year by changing and all the formula are the same. And firstly, in this part, for this month we have to calculate the solar declination. Then the altitude and azimuth angle of the sunrise and sunset can be calculated by substitute meter is equal to 0. Next, we calculate the altitude angle and azimuth angle hour by hour in range of the sunrise and sunset to find out the sun position. And we do the same for each month of the year to get the final result. From this data, we use the Excel to draw the sun path diagram by taking two beta and phi s of each month one by one. To draw the timeline, we taking the altitude angle and azimuth angle at the same moment from the different months within range of the sunrise and sunset. For the last part, we assume that the obstruction is a rectangular has azimuth angle range from the 45 to 60 degree and the latitude angle at the top of 45 degree, so that the periods of shadowing can be clearly seen from the graph and is shown in the table here. Now just to summarize, let's quickly look at the main point. Again, doing this part help me know how to calculate altitude angle and azimuth angle of the sun, determine the sunrise and sunset time, and draw the sun path diagram from the given value, and also determine the period of time of shadowing in different moments. That's all I have to say about this problem. Thank you for your listening.